Okay, here's a whole bunch of these all at once. Do them all quickly. Name the property of equality that justifies this statement. If L equals M, then M equals L. Well, remember, it's like there's a mirror here, okay, that kind of is reflecting these like this, okay? But the trick here is that it's not the reflexive property. The reflexive property would say M equals M, right? The exact same thing. What this does is there's a symmetry to it. If there's a mirror here, then the symmetry is that, right? The M is close to the mirror, then the equals, then the L on the other end. Okay, so this is the symmetric property of equality. Why of equality? Because it's equal and not congruent. Okay, next one. Which statement is an example of the addition property of equality? Well, you will start with something and then you would add something to both sides. So B says, if P equals Q, then P plus S equals Q plus S. You've added S to both sides. Okay, and when you add to both sides, that is the addition property of equality. There you go. Okay, now, transitive property of congruence. It says, if this segment, CD is congruent to segment EF, and this segment, GH, is congruent to segment EF, they're both congruent to segment EF, so therefore they must be congruent to each other. So segment CD is congruent to segment GH. Okay? If two things are congruent to the same thing, they're congruent to each other. So these are both congruent to EF. They're congruent to each other. Yep. Now, multiplication property of equality. If 5x divided by 9 equals 36, then, well, you could really multiply by anything. Obviously, what they're asking you to do is to multiply by the thing that undoes what's happening to the variable. So how do we undo divided by 9? With a times 9. So if we did times 9, that would leave us with just 5x. And if we did a times 9 here, we would get 324. So we get 5x equals 324. Okay, here, if y equals negative 5 and 7x plus y equals 11, then using substitution, we would take this equation here, and where we saw y, we would put in what y is equal to. 7x plus negative 5 equals 11. Okay. All we did there is we took what y is equal to, negative 5, where y was in the equation, we put negative 5 in its place. Now, name the property of congruence that justifies this statement. Aha, just like on the top, look up here on the top. Here we had this symmetry, right? The symmetry going the balance of like M here and M here close, then equals, and then L further away from that line of symmetry. Okay, same thing here. Okay, we're doing this kind of symmetry here where segment LK is closer, segment MN is further away. So you have this line of symmetry here, and essentially symmetric property means you can switch the sides of something. Okay, we can take what was on the left and put it on the right, take what was on the right and put it on the left. That's what they're doing here, but except they're not equal, they're congruent. So we say the symmetric property of congruence. Okay, and finally, name the property of congruence that justifies this statement. If angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. We've got them both congruent to angle B, so they're congruent to each other. And that is the, remember, transitive property, in this case, of congruence, because we're talking about congruence and not equality.